Okay, this is a review for the Chapter 12 exam, and I'm going to be skipping around. One of the first things I want to do is look at the questions that involve knowing characteristics and properties of the organic compounds. Remember, I said that you were going to have to know this, and I wasn't going to be spending time on class with this because this is something that you can read and do. You're going to need more help from me on naming and figuring out why something is the way it is. Okay, so if you look at the beginning of Chapter 12 in your textbook, okay, the characteristics of carbon, they're tetravalent, always forms 4 bonds, primarily nonmetals, they have covalent bonds. They can share more than, in other words, they can double, triple bond. Okay, carbon, they can form multiple covalent bonds. And they can be polar or polar covalent bonds. We learned about that last semester. There are 3-dimensional shapes. The organic molecules always contain the carbon, hydrogen, nitrogen, oxygen. And then as far as the characteristics go, if we go back here and look on page 385, remember, these are in general characteristics. They're not, you know, nothing is absolutely written in stone, but these are in general characteristics. Odorless or mild odor, colorless, tasteless, non-toxic. They're non-polar, insoluble in water, but soluble in polar, but soluble in non-polar organic solvents. They're less dense than water. Okay, they're flammable, otherwise not very reactive. All right, so remember, all this is relative. They are flammable, but they really, there's only 2 types of reactions that these things have. That's combustion and halogenation. So if we look here, we've got the question, all the following statements are general properties of organic compounds except the bonds are covalent. They have relatively low boiling points. That's true. They have limited or no water solubility. That's true. They usually behave as electrolytes. Okay, that one is the one that is not true, so that's going to be our answer. And they have relatively low melting points. So D, nothing in there stated that they would behave as an electrolyte. Okay, they're relatively non-reactive, they're non-polar, so they're not going to conduct electricity in solution. That's remember that covalent compounds do not conduct electricity in solution. Okay. Now, the next one that had to do with characteristics on your test. It says number 60 on here. It was on page 4. Which best describes, which group is the best description of the properties of alkanes? Okay, so right here, they are not water soluble. B, they are flammable, so we can't answer that. C, flammable, non-reactive, insoluble in water. That sounds pretty good. Non-flammable, we can't answer that one. So the answer is going to be C for that one. That's 2 points on the test. Number 61. Again, I thought these were going to be easy points for you. Which of the following properties is not characteristic of alkanes? Okay, their melting points increase with molecular weight. If we look right here on page 384 in the book, as the number of carbons, as the molecular weight increases, you know, the more carbons you have, the more your molecular weight is, the higher the melting and boiling point is. Okay, so that is a characteristic. They are generally less dense than water. That also is a characteristic. They float on water. They are tasteless and colorless. They're non-toxic. E, they do not form strong hydrogen bonds. Remember, these are covalent. They are not, they're not like water, where you have the partially positive ends and the partially negative ends. They're not like that. They do not form these strong hydrogen bonds. So if you look at one of these alkanes, there's hydrogens all the way around these carbons, and there's no polarity. The charges are distributed evenly. Okay, alkanes are blank in water and blanked in water. Okay, so they are not soluble in water, so we can eliminate those two. They are less dense than water. 63 is A. So I think right now we are at 4 points out of this test. Yeah, 4 points out of the 51. There was a total of 51 questions. So 4 out of the 51 had to do with properties. Don't forget that. Every single test that you have is going to have something to do with properties. And that's something that you are capable of reading and you are capable of memorizing. Okay, the next thing I want to look at before I get into this kind of stuff, the next thing I want to look at on your test are the number of problems that you already were supposed to have memorized, because we had quizzes on these. Okay, this one right here, alcohol. When you have that OH functional group, alcohol. This is an aldehyde, so that's 2. An ester. All right. One thing that they did not do here was try to confuse you with an ester and an ether. This is an ester. Okay, this is an ether. All right, so that's 3. Okay, so 3 of them were things that you already should have memorized. That was the structures. So 4 questions were about properties. 3 were about functional groups. So that's about roughly 14% of your test right there, of whatever grade you received. All right, now the next thing I want to do is look at, before I get into the individual naming, is looking at how many questions we're dealing with isomers. Everybody had this question: draw 3 isomers for C5H12. This was it was right out of your book, because I said to myself, let me give them something that I think we actually did this one in class. I'm positive we did this one in class too. Okay, so it's in your book and we did it in class. okay, page 366. Okay, C5H12, you've got 3 structural isomers. Now, notice that these are completely different. This one would have 1, 2, 3, 4, or 1, 2, 3, 4 being its longest continuous chain. Okay, see, this is branched. This one has 1, 2, 3, 4, 5 being its longest continuous chain. This one has 1, 2, 3, 4. Either way you go, it would be 4 as its longest continuous chain. So this one having 5 as its longest continuous chain would be a pentane. This one having only 4, no matter which way you go, as its longest continuous chain, would have the base name of a butane. Notice this one is branched also, and no matter which way you go, whether you go 1, 2, 3, or 1, 2, 3, or 1, 2, 3, 1, 2, 3, 1, 2, 3, or 1, 2, 3, this only has 3 as its longest continuous chain. This one would have a base name of propane. Okay, so that's one way to look at how these are structural isomers. Here's another way to look at this. This one, all of these right here have primary carbons because the carbons are attached to, either this primary carbon here, or this would be a secondary carbon. So it has either the primary or the secondary carbons. This one, this carbon is connected to 3 other carbons. This carbon is connected to 4 other carbons. So these are completely different. And I'll tell you what I saw a lot of people doing on this test. I saw a lot of people just taking, you would draw this 1, 2, 3, 4, 5. Okay, so that's what people would draw as number 1. So you got that point. That was worth 3 points there. Okay, well, this was 1, and then the other 2 were 1 point each. Okay, then I would see people doing something like this, and they would just change the position of how they were arranged. No, this is the exact same thing. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. They're the same thing. There's no branching or anything like that. So you can't just change the way that you draw it. You have to draw it to where it is completely different to be an isomer. So there were a few questions in here about isomers. And not only did you have that on page 366, and we did that question in your notes, or we showed that as an example in your notes. But you also had something very similar to this on 1240, number 46. I guess I didn't assign your group number 46, but you could have done more practice. 46 had examples. I think I started your group out at number 50. Okay. But go through all of these that have the answers in your book, because you know you're liable to see them again. It's good for you to practice. Okay, another one that dealt with isomers was, if you look at number 28. Okay, this has 1, 2, 3, 4, 5, 6 going this way. 1, 2, 3, 4, 5 if you count this way. So its longest chain is going to be 6. And on the 1, 2, 3rd carbon from this end, or the 1, 2, 3rd, 4th carbon from this end, so if we say 1, 2, 3, we've got a methyl group coming off that 3rd carbon. So we're going to go down through here and we're going to see 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. This is not the same thing. Okay, this is 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. This is a C7, H, 2, 3, that's 12, 13, 14, 15, 16, 17, 18, 19, 14, 16, 2, see, 1, 2, 3, that's 9, 10, 12, 14, 16, H16. Okay, that's a C7, H16. Okay, so right here you got 1, 2, 3, that's 9, that's 10, 12, 14. Not the same thing. Here you've got 1, 2, 3. Let's see, 1, 2, 3, 4, 5, 6. So this one we're going to look at it as being a possibility. 3, 9, 10, 12, 14, 16. So again, we got a C7, H16 here. 1, 2, 3. 1, 2, 3, but here's the problem. This methyl group is coming off the third carbon. So this is the exact same. These are the same. It's just that it's flipped around. Okay, so 1, 2, third carbon, 1, 2, third carbon. All right, so we're looking for the isomer, not the same thing. So let's take a look at this one. 1, 2, 3, 4, 5, 6, 7. So that's a C7. And we're going to have an H16 because we don't have any double bonds. So that's a possibility. 1, 2, 3, 4, 5, 6, 7. This is a C7, H16, I think. 3, that's 9, 10, 12, 14, 16. 12, 14, 16. Both of those are C7H16s. This one is 1, 4 carbons would be 5, and that'd be 6. This is only a C6. So there's 4 carbons here, 5, 6. So this can't be it because there's only 6 carbons. So that leaves us with these 3 choices. Which one is an isomer? Okay, on this one, the methyl group is coming off of the second carbon. On this one, the methyl group is coming off of the 1, 2, third carbon. Okay, so this is the exact same thing as this, except instead of the methyl group being shown up here, see how the methyl group is shown on top? They're just showing it on the bottom. Okay, so this is also the same. They just showed the methyl group on the bottom instead of showing it on the top. Okay, this one, right here, okay, this is the same, this is the same, this one is the isomer right here, because your methyl group is connected to the second carbon, where this methyl group is connected to the third carbon. Okay, so that's another one about an isomer. So that's 2 points so far, or 2 questions so far. So the first question was worth 3 points, plus this one will be 4 points. Here's another question about an isomer. 1, 2, 3, 4. That's a C5 because you got 1, 2, 3, 4, 5. H, 9, 10, 12. Okay, so there's a C3. No. Here's a C1, 2, 3, 4, 5. H, 3, 4, 7, 10, 12. So that's a possibility. Then we got C1, 2, 3, 4, 5. That's a C5. H, 3, 6, 8, 10, 12. Possibility 1, 2, 3, 4, 5, 6. No, because that's a C6. So now we're down to looking at these two structures right here. Okay, on this one, this methyl group is coming off the second carbon. So if we look right here, 1, 2, this methyl group is coming off of the second carbon. So this one is the same as that one. So our answer for number 30 then would be C. Okay. Hold on, I'm lying to you about the answer on this one. I circled the wrong one. This is the answer on this one is C. We chose the correct structure, but when I circled it, I circled the D choice. The correct answer here is this one, C. I know I had a couple people come up and ask me which one belonged to which answer, and I just drew lines. So if you ever have trouble figuring out, which one belongs to which answer, circle like that entire thing, and then I can make sure, or come up and ask me, and I'll draw lines and show you which one belongs to which thing. Okay, so that's another point about isomers. So far we're at 5 points for isomers. Okay. So 5 out of the 51, that's about 10, roughly 10% for isomers. So now we're at about a quarter of the test. All right. The next thing that I want to do is go through and work on these that deal with naming. Everybody had a page that looked like this, and this was a different problem for everybody, but all these were actually structural isomers. Now, I'm going to start out with the one. These are not labeled test A, test B, test C, test D. There were 4 different ones. So I can't say if you had test A, it's this one, test B, it's this one. You just have to look at what structure I gave you. Okay. One thing I really noticed here is that people had a very difficult time identifying which one is their, what is their base chain? Like, what is their longest continuous chain? Now, this does not go away. So, if you can't do this, you're going to either have to learn how to do it and make a whole bunch of good test scores, or just ignore it and then fail a bunch of tests. Okay, you have to be able to identify what is your longest chain. This particular one right here was 50D in your homework. Okay, so this one was 50D in your homework. Okay, so if you did your homework, you had practice with that. Now, again, always use pencil. for organic, but if I count this way, I've got 1, 2, 3, 4, 5. If I count this way, I've got 1, 2, 3, 4, 5, 6, 7, 8. If I count this way, 1, 2, 3, 4, 5, 6, 7, 8. Or if I count 1, 2, 3, 4, 5, 6, 7. Yeah. So I'm going to have 8. Oh, sorry, let me go over that again since I couldn't see it. If I count this way, I've got 1, 2, 3, 4, 1, 2, 3, 4, 5. If I count this way, I've got 1, 2, 3, 4, 5, 6, 7, 8. If I count this way, 1, 2, 3, 4, 5, 6, 7. If I go this way, I got 1, 2, 3, 4, 5, 6, 7, 8. Okay, so our longest chain is going to be 8. That's our longest chain. So the first thing I want to do is draw that line where my longest chain is. So that means we're going to use oct. They're all single bonds. So I'm going to put the ending A and E on the end of it. Okay, now I'm going to look at how to number my chain. I want to have the numbering be as low as possible. So if I go this way, 1, 2, 3, 4, or if I go this way, 1, 2, 3, 4, 5. So I've got this group, which is a methyl. It gets a lower number if I number this way, 1, 2, 3, 4. And I've got this group, which is a 1, 2, 3, which is a propyl. And again, the lower number, they're both attached to this 4. Okay, so I've got a 4-methyl and a 4-propyl. I'm going to put it all together. I'm going to put my substituents in alphabetical order. So I'm going to say 4-methyl, 4-propyl, octane. When I draw the line structure, I'm just going to draw my longest continuous line first, my longest continuous chain of carbons. I've got 8 carbons. I'm going to go 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And on the 1, 2, 3, 4th carbon, I've got a methyl group coming off of it. And then I've also got a propyl group coming off of it. 1, 2, 3. Now different people had this orientation in different ways, so I really had to look at it and count the number of dots that you had. But here's the main thing. Your main chain has 8. 1, 2, 3, 4, 5, 6, 7, 8. And then at the 4th one, you've got 1 carbon, and on the other side, you've got 3 carbons. 1, 2, 3 carbons. Okay, that's your main thing on that line structure. Condensed structure, there were, many variations of this also that I had to look at, count. But A was worth 5 points, B was worth 5 points, C was worth 5 points. So the condensed structure. If I go this way, I've got a CH3, and then I've got 2 CH2s. And yes, you could have put that in parentheses and just put, CH2 parentheses 2. And then I had a carbon, and I would have accepted either way if you put this down here, CH2, CH2, CH3, and up here a CH3, and then we had a CH2, 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 CH3. 1, 2, 3, 4, 5, 6, 7, 8. Okay, now the molecular formula. Again, I would have accepted this, I would have accepted any variation on this that actually worked, okay? I was not super picky on it being at its most condensed form. Okay, the molecular formula, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I've got 12 carbons. All right, when you count up the hydrogens, 26 hydrogens. And remember, pure alkanes with no double or triple bonds that follow this formula, CnHn plus 2. So if you could just go and count up every single hydrogen you have. 1, 2, 3, 4, 5, 6, 7, 8. This might be the one. There was one of them, yeah, this one. There should have been a hydrogen hanging off of here. That would be 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. So a couple of you did count up all the hydrogens, and a couple of you noticed that I missed a hydrogen there. So if you had C12H25, I gave you that 1 point. It was worth, this was worth 2 points, I think. But I gave you those full 2 points as the full 2 credit because I did miss putting a hydrogen here. Okay. But it was actually C12H26. The empirical formula, they can both be divided by 2, C6H13. That was worth 1 point. Now, if you got this wrong, but you did this correctly, then I still gave you the 1 point. Now, the GMW. Remember, you get this from the molecular formula. And we did this in class. So the carbon, you have 12 carbons times 12 grams per mole, 144. You've got hydrogens, 1 gram per mole times 26. There's 26 of them, 1 gram per mole. 26. That would give you 170 grams per mole. Okay, so if you only put 25 there because of what I did up here, and you got 169, then I gave you that. That was worth 3 points. Okay, so I had to go through and really make sure that if you did not get this correct, I had to go back up here and see, what you did. All right, so this one was worth a total of 15, 16, 18, 21 points on this page. Okay, I'm going to go through the ones that the other people had. So some people had the one that looked like this. And this particular one was like, this one was 50B in your book. Okay, so I think it was exactly like 50B, or very close to 50B in your book that you did for homework, or you were supposed to have done for homework. All right. Again, we want to find the longest chain. 1, 2, 3, 4, 5, 6, 7 that way. We could go 1, 2, 3, 4, 5, 6, 7, 8 if we go that way. Or 1, 2, 3, 4, 5, 6, 7, 8 if we go that way. 1, 2, 3, no, 1, 2, 3, 4, 5, 6. Okay, so 8 is going to be our maximum, our longest chain. So we would go 1, 2, 3, 4, 5, 6, 7, 8. Okay. So since there's 8, we're dealing with an oct. They're all single bonds. We're going to add the A and E on there. We've got this methyl group here. And we've got right here, this is an isopropyl group. And the reason it's an isopropyl is because there's 3 carbons, but it's connected at the middle carbon. Iso means the same, so there's the same amount of carbons on either side of that tertiary carbon there. Okay, that's, but if you need help on that, you can look in your textbook at page 378. Okay, so page 378 explains the difference between propyl, isopropyl, butyl, tert-butyl. So now if we number this way, 1, 2, 3, 4, 5, our substituents are at 3 and 5. But if we number this way, 1, 2, 3, 4, 5, 6, the substituents are 4, 6. So we want to number so that we have the lowest number on our substituents. So we go 1, 2, 3, 4, 5. We're going to number this way. So this methyl group is at 3, and the isopropyl group is at 5. Then we're going to put it in order. The I is going to come before the M. So we've got 5 isopropyl. Three methyl. Octane. Okay, again, that was 5 points. Line structure. I'm very simply going to draw my longest chain. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. At my third carbon, I have a methyl. So I'm going to draw 1 dot. Then at my fourth carbon, I have an isopropyl. 1, 2, 3, fourth carbon. So it would look something to that effect. It would be okay if you switched and had this up and this down. That wouldn't matter at this point. Okay, the condensed structure, you could go through here and go CH3, and then I could have said there's 1, 2, 3, no, there's 2 CH2s. I could have done this. And then I have a CH. And off of that CH, I had another CH. And then I had a CH3 on this side and a CH3 on this side. I could have put CH3 in parentheses and put a 2 underneath. That would have been fine. And then I've got, let's see, that's my CH. And then I got a CH2. And then a CH. CH3 in parentheses. CH2, CH3. Again, I went through and checked what everybody gave me here, because you could have given it either more condensed or less condensed. I was pretty lenient on there. So 5 points, 5 points, 5 points. Molecular formula. Okay, there was 8 going this way. So 1, 2, 3, 4, 5, 6, 7, 8. That's 9, 10, 11, 12. C12. And then H26. So again, this was just a structural isomer that we had. The empirical formula, that was worth 2 points. C6H13, that was 1 point. The GMW, again, would have been 170 grams per mole. That was 3 points. Remember, again, the GMW is off of your molecular formula. Okay, some people had the question that looked like this. Let's see. Trying to find my originals here. Okay. Some people had the question that looked like this one right here. I mean, that's the first one I did. No, I haven't done that one. This one was like 50D in your homework. Okay, 50D in your homework. So when we count your longest chain, 1, 2, 3, 4, 5, 6, 7, 8, that's 8. 1, 2, 3, 4, 5, that's only 5. 1, 2, 3, 4, 5, 6, 7, that's only 7. 1, 2, 3, 4, 5, 6, 7, 8, that would also be 8. Okay, so we're going to go with longest chain 8, that's octane. And then on the 1, 2, 3, 4, 5th carbon, if we number this way, we get our substituents. Or if we number this way, 1, 2, 3, 4 is our lowest number. So we're going to go with our numbering this way, 1, 2, 3, 4. So we got a methyl here at carbon number 4, and we've got a propyl at carbon number 4. So in this case, we'll put them in order. We've got a 4-methyl, 4-propyl, octane. The line structure, again, I'm going to lay out 8 dots. 1, 2, 3, 4, 5, 6, 7, 8. And on the fourth one, 1, 2, 3, 4, I've got a methyl, 1 dot coming off of it, and a propyl, 1, 2, 3 dots coming off of it. Your condensed structure, again, a million ways that well, several ways that you could have done it, but I did a CH3. I've got 2 CH2s. And then I have a quaternary carbon here, so just a C. I got a CH3 coming off right here. I have a propyl group right here, CH2, CH2, CH3. So these are in parentheses. And then up here, CH2, 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 CH3. Molecular formula, again, C12H26. Empirical formula, C6H13. So 170 grams per mole. Okay, that was like 50D in your homework, or that was 50D in your homework. Okay, then you had this one right here, which was 50F in your homework, or very, very close to 50F. I think there was just one little difference between this one and 50F. Okay, so when I count my longest chain, if I would have gone this way, 1, 2, 3, 4, 5, that would be 6. But if I go this way, 1, 2, 3, 4, 5, 6, 7, that gives me 7 carbons. So that's a hept and an ane. Now if I look at all my substituents, I've got a methyl group here, I've got an ethyl group here, and an ethyl group here. So I want to see where am I going to get my lowest numbers. if I start numbering this way, 1, 2, 3, 4, my substituents will be at 4 and 6. But if I number this way, my substituents are at 2 and 4. So I want to start numbering this way, 2 and 4. All right, so it's at number 2, this would be 2-methyl. Okay, so 2-methyl. And then over here at 4, I've got 2 ethyl groups. So I would say 4,4-diethyl, because I got 2 ethyls, so, and they both are at number 4. So I would say 4,4-diethyl. Now I put it all together in alphabetical order. This 4,4-diethyl comes before 2-methyl heptane. Okay, so it's 4,4-diethyl 2-methylheptane. Your line structure, I'm going to lay out 7 carbons, 1, 2, 3, 4, 5, 6, 7. On the second one, I've got 1 dot coming off for a methyl group, and then I've got 2 ethyl groups coming off of my 4th carbon. Condensed structure, CH3, CH2, CH2, and then a quaternary carbon here, so it's just C. I've got 2 ethyl groups coming off, so I put CH2, CH3 twice, and then I've got a CH2, and then a CH, and then 2 CH3s coming off. Just like the other ones, because these are all structural isomers, you got C12H26, empirical formula C6H13, 170 grams per mole. Alright, so that's the 4 variations of the first page. I recommend that you get groups of 4 together so that you can trade, or just go back and practice your homework problems. Either way, you have to know how to do this to continue on. Okay, then the other thing that people had, which was different, is if you turn the page, some people had this version that said draw the line structure for 1-methyl-3-propyl cyclohexane. This was like number 54 that you had in your homework. Not exactly, but pretty close. Okay, so it's a hexane. There's 6, but notice this cyclo in front of it. So in your homework problems, you had some cyclo structures, so you just make 6 that are in a cycle. Hello. And then you had a methyl coming off at 1, and then on the third one you had a propyl. Then some people had the variation of the problem. This was 52C from your homework. So 4,4-diethyl 3-methyl octane. Since it's octane, we're going to lay out. As a matter of fact, it might have even matched. Nope, didn't. Okay, 1, 2, 3, 4, 5, 6, 7, 8. I laid out my 8 carbons, and then at the third one, 1, 2, 3, I had a methyl group coming off. That's 1 dot, and then at the fourth one, I had my diethyls. So that was problem 52C. Then some people had the version that was (2,4-dimethylpentane). Okay, so pentane would be 1, 2, 3, 4, 5 carbons, 1, 2, 3, 4, 5, and at carbon 2 and carbon 1, 2, 3, 4, I had methyl groups coming off, so it would look something to that effect. You doing okay?
Doing good.
Good, good. Okay, so there, this was worth 5 points. Okay, so this written part altogether, there was 21 points on this page, this, and 8 points on this page. So written altogether was 29 points. So it was, like always, about half of your test was written. The other half was multiple guess. Okay, then let's go through and answer from here on out. All the questions were the same. Alright, which is a correct line structure for the following molecule? When I have something like this, I just kind of draw my line structure before I do anything else. My longest chain is 1, 2, 3, 4, 5 this way, or 1, 2, 3, 4 this way, 1, 2, 3, 4, 1, 2, 3, 4, 5. So my longest chain is going to be 5 either way. So I'm going to look for a longest chain with 5. I'm also going to look for one with a quaternary carbon. Alright, so I'm going to go through this whole elimination thing real quick. 1, 2, 3, 4, 5, 6. It can't be this one because that longest chain is 6. Also, there's no quaternary carbons in there. Okay, 1, 2, 3, 4, 5. So that looks good. Also, this one, notice, is a quaternary carbon, meaning there's no hydrogens attached to it. So that looks good. And this means there's a methyl group coming off and an ethyl group coming off. And methyl group coming off and an ethyl group coming off. So this was your answer here. Most people got that one right. So I'm not going to spend a lot of time with that. Now this surprised me that a lot of people didn't get this one right. Okay, primary carbon means that you've got only, a primary carbon means it's attached to only one other carbon. Okay, so this is a primary carbon. A secondary carbon means that it's attached to 2 other carbons. Okay, so hydrogen, hydrogen. This is a secondary because it's attached to 2 other carbons. A tertiary carbon would be attached to 3 other carbons, and then that quaternary carbon would be attached to 4 carbons and no hydrogens. So it asks us this one right here, what is it? Well, we're attached to 1, 2, 3 other ones, so it's a tertiary carbon. So I was a little surprised that more people didn't get that one right. That's number 40. Okay, 45 here, the name of the structure. So again, this is a skill that, please fix this skill. Do not get to the end of the semester not knowing how to do this. This will kill you. All right, if you do this. We got to find the longest continuous chain, and that just means sitting here playing with all the possibilities, all the iterations. So 1, 2, 3, 4 if we go this way. 1, 2, 3, 4 if we go that way. 1, 2, 3, 4 if we go that way. 1, 2, 3, 4 if we go that way. 1, 2, 3, 4. Looks like either way we're going to have 4 carbons as our longest continuous chain. Base name is butane. Okay. And then number 51. What is the IUPAC name for this? Now, it may help possibly to draw this out. We've got 1, 2, 3, 4 carbons here. and then connected to this carbon are 3 methyl groups. Now, again, have to find the longest continuous chain. 1, 2, 3, 4, 5. Or 1, 2, 3, 4, 5. Or 1, 2, 3, 4, 5. Either way, the longest continuous chain is 5. So it has to be a pentane. So you can mark off heptane, hexane, that. Now you're down to a 50-50 chance of getting this right. Okay. Now, you got 2 methyls, both of them on the second carbon. So here's the thing. If you got 2 methyls, you have to say 2,2-dimethyl. So the answer there is B, 2,2-dimethyl pentane. All right, this one, number 52. Longest continuous chain, we go 1, 2, 3, 4, 5, 6 if we go that way. 1, 2, 3, 4, 5, 6, 7 if we go this way. Okay, so let's go ahead on this way. All right, now we got to figure out how to number it. So it's a 7, so it's going to have the hept. So we're going to mark off that one, and that one. So that takes us down to 2. And you're going to notice that whenever you have these kind of multiple choice, they're going to do that. They're going to usually have it where you can eliminate either 2 or 3 of them real quick. So now both of these have trimethyls. What this is trying to see is, do you understand how to number them correctly? We want to number so that we have the lowest possible number for our substituents. So if we number it this way, we get our substituents at 1, 2, 3, 4, and 6. But if we number it this way, we get it at 2, 4, and 5. And we want to have the lowest numbers. So it's C. The IUPAC name for this one, 1, 2, 3, 4, 5, 6, 7, 8 is our longest chain. So that's going to be an octane. So mark off our heptanes, leaves us with these. Same thing, it just wants to know what's the lowest number you can get on those substituents. If you go this way, you get 1, 2, 3, a substituent at 4 and 6. You'd have a 4,6-dimethyl. But if you go this way, you get 1, 2, 3, and 5-dimethyl. This is the lowest choice. All right. I'm going to come back to the reaction one. I'm going to go to this one. This one was very similar to the ones you had in your homework. This is a cyclo because it's in a cycle. There's 1, 2, 3, 4, so it's a cyclobutane. You've got 2 methyls, 1, 2, so you have 1, 2 dimethyl cyclobutane. All right, so we can automatically, this cyclohexane, make it go away. The dimethyl without any numbers, make that go away. The lowest numbers that we can have is 1, 2 dimethyl cyclobutane. Answer C. Okay, now I'm going to go to my reactions. This one, when most people got this right, I think there are 2 reactions, and this is, you know, in the back of your book, I kept saying, read this chapter, take notes, read this chapter, take notes. But there are 2 reactions. The 2 reactions are combustion and halogenation. If it reacts with group 7A, it's halogenation. All right. This one right here, complete balanced equation for the combustion of cyclopentane. This was very similar to number 60 in your homework, and number 54, very similar, number 60 for the reaction, and number 54 for the cyclopentane. I was really shocked that y'all didn't get a combustion problem, even the number of people that didn't even try to set it up. When it comes to a combustion, remember, you get, you have your fuel plus your oxygen. In complete combustion, you get carbon dioxide plus water. Okay, so that would have gotten you, 2 points at least. Yeah, this was worth 5 points. So if you wrote, even if you didn't balance anything out, you just told me that oxygen plus your cyclopentane gave you carbon dioxide and water, you got 2 points. Okay, so cyclopentane, we got 1, and it's in a cycle, 2, 3, 4, 5. So that's a C5. Two hydrogens coming off of each one of these. You count them up, there's going to be a total of 10 hydrogens. C5H10. So if you gave me this, I gave you, 1 or 2 points. So the equation C5H10 plus O2, and now all we have to do is balance it. All right, you got 5 carbons here. The problem with having 5 carbons is that you have to watch. Well, here's the deal with these. This is an odd number here. And this is an even number of oxygens, okay? Because there's 1 oxygen here, and this is an even number. So notice that you have to, it's really playing around to try to get your oxygen straight. So I always start first, the first thing I always do when I have these kind of problems is I always just start with putting a 1 in front of this. I always do that. And then that would give me 5 of these. And then that would give me 10 hydrogens, which would mean I'd have to put a 5 in front of here. Here's my problem. If I put a 5 in front of here, now I've got an odd number of oxygens. So I have 5 times 2 is 10 oxygens plus 5 is 15 oxygens. I can't do that because this is an even number. This is a diatomic. Okay, so next thing I do, I just erase that and I put a 2 there. And that gives me 10 carbons, so I have to put a 10 in front of here. 20 hydrogens, so I have to put a 10 in front of this one. Now I've got 20 oxygens here plus 10 here, gives me a total of 30 oxygens on this side. I've got 20 oxygens over here, so I'm going to need, or excuse me, I need 20 oxygens over here. 30 oxygens over here. Let me say that again because I'm really tired. Okay, 10 times 2 gives me 20, plus this 10 gives me 30. So I need 30 oxygens over here. I put a 15 in front of that. So your coefficients for this balanced equation would have been 2, 15, 10, and 10. Okay, this was an extra credit. I have one person attempt it. And this person actually did pretty good on this problem, but I'm not going to have you practice this problem, because it's not really going to help us that much when we get further into what we're doing in organic chemistry for this class. Okay, because where we have to get you is knowing the different biomolecules, because a lot of you are going to take this and go into nursing school and stuff like that. So that's why I just counted that as extra credit. All right, you can look in your book if you want and figure out what the answer is on that one.